In this video, I am going to show you how induced EMF can be derived in transformer primary and secondary windings, and how we can conclude the transformation ratio of a transformer. First of all, induced EMF in a transformer. So we have a transformer. Supply voltage and supply current, and these are the secondary terminals with, and the flux direction is like this. So we know transformer is a static device and it operates on a pulsating supply. That means the input voltage is a sinusoidal voltage, so therefore input voltage, and therefore input current, so therefore flux. Because of I is equal to V by R, from V we get I, from I we get flux into reluctance. So therefore flux is equal to Ni by S. S is a material property which is constant, and N is the number of turns. So therefore induced EMF across primary conductors which are having an N1 turns, E1 equal to minus N1 d phi by dt. So how we can represent phi? Phi of t is equal to phi m sine omega t, and this flux is constant throughout the core. So for primary and secondary the flux is same. So therefore induced EMF across the primary conductors E1 is equal to minus N1 d by dt of phi m sine omega t, and it is a time variant, not a space variant, so omega is constant here. So phi m, for sine it is cosine, and for this function it is omega. So we get n phi m frequency, and it is cos omega t. So therefore E1 is in the form of Em cos omega t. Therefore amplitude or maximum value of induced EMF E1 is Em. This Em is equal to minus n phi m omega, and it is a magnitude, so you can neglect the minus sign. And we always deal with RMS values for AC analysis. So therefore for sinusoidal and cosinusoidal signals, Vrms is equal to V maximum value by 2. Therefore E1, which is RMS, and normally we use RMS representations and no need to specify it as RMS. Therefore E1 is equal to n phi m omega by root 2, and we know n phi m, the frequency relation, radians, omega is in radians per second. Normally we use frequency in hertz. So what is the relation? Omega is equal to 2 pi f. For it's 2 pi f by root 2. So you can make it as root 2 because of these two, pi f n phi m. Here n is n1. It's not n, it's n1. This is a primary induced EMF. E1 is equal to root 2 pi frequency of input frequency, supply input frequency. N1 is a turns, and phi m is the maximum flux. So now in case of secondary winding E2 of t is equal to minus n2 d phi by dt. For minus n2 d by dt of phi m is same, phi m sine omega t. So same formula, minus n2 phi m, it is a time variant, not a space variant, so cos omega t. So therefore maximum value E2 maximum equal to n2 phi m omega. Can write in terms of hertz, not in radians per second. N2 phi m. And E2, that is RMS. If you represent like this, it represents RMS. So it's root 2 pi f n2 phi m, because maximum by 2 for sinusoidal and cosinusoidal signals. Therefore we got E2. Write E1 by E2 side by side. E1 equal to root 2 pi f, how much we got, E2 pi f n1 phi m n1 phi m, and E2 is root 2 pi f n2 phi m. Now compare these two. E1 by E2, these are the EMF induced in primary and secondary windings. And now transformation ratio is E1 by E2 is equal to root 2 pi f n1 phi m by root 2 pi f n2 phi m. Therefore supply frequency is constant and phi m is constant, so cancel each other, we get n1 by n2. Therefore transformation ratio of transformer is E1 by E2 equal to n1 by n2.